of what we just did. Now we are expanding. So in other words, we're starting with one logarithm, but we want to break that up into two logarithms because there's two letters. That's how I know I'm going to use two. If there were three letters, I'd need three. But I'm going to break that up into two logarithms. Does anybody have an idea what that would look like if I broke it apart?
Would it be ln x plus ln y?
It absolutely would be. Very, very good. Remember, the rule says when logarithms are added, the numbers are multiplied. So the backwards of that is, if the numbers have been multiplied, then the logarithms have been added. Beautiful. What about this one? What is this one going to equal?
ln x minus ln y.
That's awesome, except this problem uses LOG.
Oh.
Yeah, so, but the idea is exactly the same. You're exactly right. If this had been an ln, it'd be ln x minus ln y. You're exactly right. How do we know that's a minus? Because this is a division. Those rules should be sitting right next to you so that if you get confused, you can look. Oh, this one's a little bit tricky.
Log x minus 4 log y.
Oh my gosh, beautiful, beautiful, beautiful. Let's back that up and take it a step at a time. You don't need to. If you can go straight to the answer she gave, all is well. But I'm going to go ahead and do it in two steps. It's going to be the log of x cubed minus the log of y to the fourth. Now, I think that hopefully that makes sense to you. It's a minus because this is a division. But then I remember that that exponent can be pulled out front. So 3 log x minus 4 log y, because this one can also come out in front. Some of you are going to go straight from here to here like she did, and some of you are going to want to put that middle step in there. Oh man, this one's tricky. Who has an idea? Anybody feel courageous? Nina, you feel courageous? No? No courage today? No? Okay. Tell me about a fifth root. I need to write that fifth root as an exponent. What
would it be 1 over 5?
It would be 1 over 5. So I am going to rewrite my radical as a 1/5 exponent. And I don't want anybody to be remotely confused by that. We have spent a lot of time talking about fractional exponents are radicals. I am going backwards now. I'm saying, okay, I have a radical. That must mean I have a fractional exponent. Now, what do I do with that exponent? Where does he go?
To both of them?
Exactly. Now, these two guys, x to the 1/5 and y to the 1/5, are being multiplied. So now I'm going to pull them apart and write two separate logarithms. what am I going to put in between these two separate logarithms? What sign is going to go in here?
Plus.
Yep.
Plus.
Plus. Yep. And now there's one more step. Do you know what it is? Do you know what the very last step is? These guys are exponents. Where do I put them?
In front.
Yep. So I'm going to have 1/5 log x plus 1/5 log y. That 1/5 goes to the x and the y because it's all under the radical. Those of you who are wondering, it's extra loud today because they're ripping out the student entrance. They were supposed to do it a few days ago, but they're doing it today.
Really?
Yep.
Hey.
Taking down all the drywall and I don't know what else. They're hammering, pounding, I don't know. Okay, so the next problem, E, says we have the log of the 4th root of x over z. This is kind of a complicated problem. Does anybody have an idea what we might do first, what we should do first, what we have to do first?
Can we change x to 1/4?
Yes, 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 that makes me want to dance. Perfect. So we're going to think of this as x to the 1/4 over z. Again, radicals are fractional exponents. Now, see how you have your x over your z? When I split that up, I'm going to have the log of x to the 1/4, and I'm going to have the log of z. I take the log of each letter. What do I put in between them this time? What's happening here? These are divided.
Minus.
Yeah, it's going to be a minus. I have one more small thing to do. What do I still need to do?
Put the 1/4 in front of log x.
Exactly. So 1/4 log x minus log z. Very, very good. That's kind of a tough problem. You did a good job with it. All right, one more that looks like this. Now notice this time, problem E, only the x was under the radical. But in problem F, the x and the y are both under the radical. So tell me how that's going to be different. What's that going to look like in step 1? Well, don't they both get the radical? So they'll both have a fractional exponent. In this problem we just finished, only the x got the 1/4. The z did not. But here, they're both going to get the 1/5. Remember, a 5th root is a 1/5 power. Now I can do the log of x to the 1/5 and the log of y to the 1/5. But then I got to put a sign in between.
Minus.
Yep. And then I have one more step, which is what? What is the very last thing I need to do?
Put the 1/5 in.
Yep, I got to pull the powers off. So I'm going to have 1/5 log x minus 1/5 log y. guys are doing really well. This is good. Those of you that maybe aren't paying as much attention or are a little confused need to speak up. Log 100x squared. Now, this one's a little tricky because there's a number and a variable. But remember, in between there is a times. That's 100 times x squared. So when you split it up, you're going to have the log of 100 plus the log of x squared. This part's easy. This will be plus 2 log x. Does that make sense to everybody? I'm just pulling the exponent off and putting it out here in front of the log x. Here's where it's tricky. This is a tricky problem. This is going to catch a lot of people. I want you to think back to a couple days ago. We had some problems like this. That may have actually been one of our problems. Log of 100. The base is 10. 100 is 10 squared. So what's the log of 100? 2. So the answer to the problem is 2 plus 2 log x. Now I know exactly what you're thinking. You're thinking, how am I supposed to know that, Mrs. Ford? Well, you just are. If this had been a different number, like a 17, then you would be done right here. You can't do anything with the log of 17. But we could simplify because our number was 100, and 100 is a power of 10, which is my base. My base is 10. So if this number is a power of your base, you got to simplify. If it's not, then you don't have to worry about it. Like one of our problems we did earlier, we got like log 48. We didn't have to simplify that because 48 isn't a power of 10. All right, there's one more, guys, one more. Then we're going to go to our calculators and give you a bit of a break. ln 30e cubed. Now, I really don't want that ln bothering you. Write it as log base e if you wish. ln can always be written as log base e. Now, like the problem we just did, there's an understood multiplication in there. So when you pull this apart, it's going to be the log base e of 30, or ln 30, if you prefer ln 30, plus log base e of e cubed. Wait a minute. Wait a minute. These two match. So what's the answer to this piece of the problem? Since these two match, the answer is 3. And then we have the log base c of 30. And that's the answer. Now I went ahead and did that one in terms of log base c. Certainly you can have ln 30. Doesn't matter. All right, get your calculators out. We're going to do a little change of base. It's really, really easy. I think you'll like it. We're looking at number 3, part 3. And it says, evaluate the following, round to the nearest 10,000. Now, some of you might be thinking, well, why don't I just type it in my calculator? Can anybody explain why I don't just type in log 4 for this problem? Okay, well, on your calculator, you have a button that says LOG. If you type LOG and then 4, what's the base on that? No, the base isn't 1. LOG has a base of 10. Your problem is not base 10. So luckily, there is a little formula. It's called the change of base formula, and it's very easy to use. If you want to evaluate a log that you don't have a button for, you do the log of the top number, the log of the big number, the log of 4, and divide it by the log of the bottom number. And I will never get those confused because this is written below, the 3 is written below, and that's where the 3 goes, below the fraction. So we're going to type in log 4 divided by log 3. Remember, when you hit log 4, close those parentheses before you hit divided by log 3. 10,000th again is 4 decimal places. So this is going to be 1.2619. I'm going to talk about this one more time, but I went through this yesterday, and if you're still having questions about this, you need to come to Flex. 10,000th is 4 decimal places. Whoops, I missed. So there's my 4 decimal places. After it, I have a 595. I have more than a half, so this gets rounded up. If this number right here is a 5 or higher, you're going to go up. So that's why I got 1.2619. Log base 7 of 11. Barrett Brown, what am I typing into my calculator if it's the log base 7 of 11?
I have no clue.
Okay, I want you to pay attention, sweet pea. Look at the problem that we just finished. It was the log base 3 of 4. So what I typed into my calculator was the log of 4 over the log of 3. And I
So
said,
you do the log of 11 over the log of 7.
yep, see how easy it is when you pay attention? Yep, that's exactly right. And we're never going to get confused because the base number is always below the others, and that's why it goes in the denominator. It goes below the fraction. So log 11, close parentheses, divided by log 7. We're going to 4 decimal places. So I got 1.2323. Now, there are 4 more of those exact kind of problem, C, D, E, and F. Would you do those, and I'll do them, and we will compare answers. Make sure you are rounding to 4 decimal places.
Miss Ford,
Yes,
can I use the restroom real quick?
yes.
Thank you.
I don't know about you, I got a negative for C, and that is fine. I don't want you to worry. When the calculator gives you a negative answer, that's perfectly okay.
I got a positive for C.
Oh, well, let me make sure I typed it in right.
I got positive too. I got a negative.
I got
I got a positive.
Okay, well, what did we type
I got
in
a
for
negative.
C? What did we type in for C?
Log 12 divided by log 4.
Oh, it's 0.4.
0.4.
0.4. It's 0.4. Okay, I have written my answers up there. I am open to conversation about them. I could have typed it in wrong, copied it down wrong. Anything could have happened, so what do you think? Brooke, are you matching me? Brooke, are you awake?
Yeah, I'm awake.
Okay, are you getting these answers, or do you not know what we're doing, or what?
I'm kind of confused.
Okay, I need you to really pay attention, okay? Because these are super simple. Let's go back to question A. When we calculate this, we type log 4 divided by log 3. It's the log of this number divided by the log of the bottom number. Always. So there really isn't anything to be confused about. We just have to pay attention so we know the rule. And that goes for all of you. Log 4 divided by log 3. The only place you could mess up is you got to remember to close the parentheses after the first number that you put in. So, can I have some confirmation that I did these right?
You did.
I did?
Yes.
All right, so we match all the rounding and all of that. All right, again, if you're having issues with rounding, I will be taking off points for rounding. So if you have an issue, please come to Flex. Now, we got a couple more problems to do real quick. Yep. So here we go. I'm just going to tell you what they say. It's pretty easy. 54 gives me an equation. It says the log of I, that's a capital I, over 12 equals negative 0.0125x. Okay, so there is an equation. And I is the intensity of light, and X is the depth of the water. So you know, because you've all been swimming probably in a lake or a pond, the farther down you go, the darker it gets, right? So the intensity of the light depends on the depth of the water. Now the question says, find the intensity when the depth is 10 feet. So in other words, we need to find I if the depth of the water is 10 feet. So would you all agree that I'm going to put 10 in here for X? So I'm going to have an equation, and I know it's scary looking, but trust me, you're going to figure it out. I have an equation that looks like this now. The depth is 10 feet, that's the X value, so I'm putting 10 in there for X. Now let's go ahead and multiply this out. So you can either do that on your calculator or in your head. When I multiply by 10, that's just going to become 0.125. Now, here we go, guys. This is what we did yesterday. That base is 10. So what does loop-de-loo tell me? Start with the base. So 10 to the negative 0.125 power equals I divided by 12. Loop-de-loo. 10 to this thing equals this thing. I know these are weirder numbers than we had, but the process is exactly the same. So I'm going to go ahead and type this in on my calculator. So I'll type 10, and then I'll raise it using my little raise button, negative 0.125. And I have some kind of crazy decimal that equals I over 12, but I really want to know what I equals. So after I type this in and I get this decimal 0.7 something, what am I going to do to it to get I by itself?
Times 12.
Yep. And the answer is 8.9987. And the intensity of light is measured in lumens. You don't need to know that, but that would be our unit.
What's lumens?
It's just a unit. It's like feet or inches. It just measures how bright the light is. If you look at like a light bulb package, like you buy a package of light bulbs, it will give you the lumens on the package. So next time you're at Meijer or Walmart or somewhere, go down the light bulb row and look at them. All right, quickly, one more problem, then we're done for the day. Now we're doing this one. All right, this is another word problem. That's an A and a T. And it literally says, A is 250, T is 2, and B is 4.25. Find R. That's what the question says. This one's so easy. What do you think I'm going to do?
Plug
Yeah, I'm just going to plug all this stuff in, and then I'm going to go to my calculator and type it. So there's no, this is way easier than the one we just did. This one's a straight plug-in. So R equals the log of 250 over 2 plus 4.25. And 250 over 2 is 125. So again, remember to close the parentheses. Log 125, close parentheses, plus 4.25. And I got 6.3469.
Miss Ford,
Yep.
for this one you didn't have to like put the 10.
Nope. Nope.
Yeah.
Because I'm not having to loop-de-loop. This one I'm just typing straight in on my calculator.
Oh, okay.
If I have to loop-de-loop, then I need a 10 in there. Now, Alyssa, if you put a 10 in here, it wouldn't hurt a darn thing. You just have to remember that that's the same as the LOG button on your calculator. Okay? All right, guys, listen, I got to tell you something. Do not leave.